In last lesson, you learned that the Faraday got the chance to prove himself as a lab assistant or cleaner of the lab. Is it this chance it turned into the opportunity? Let's see page number 51. One day, David tried to recreate a famous electromagnetic experiment. David, his mentor, his idol, and what he want to do? He want to do recreate the electromagnet.
If you look around your house, you will see many devices that have electric motors, such as kids' toys, table fans, toothbrushes, hair dryers, and this electric cutting knife. But how does the electric motor work? You turn it on and somehow it starts rotating. Why is that? In this video, we'll cover the basics of electricity and magnets, and then put it all together to understand how the motor works. This video is sponsored by Brilliant. Let's start with something called a circuit. The light bulb goes off. The path must be complete for the circuit to work. This is best done through the use of a switch. Electricity is flowing down the wire. This is called conventional flow. If we take the battery out and flip it, then the current will flow the other way. The light bulb will still work in either case, but there are some devices that will work differently depending on which way the current flows. Okay, so that's the basics of a circuit. Now let's come over here. This is a magnet. It has a north pole and a south pole, and it likes to attract other metal objects like these paper clips. If you bring another magnet towards it, opposite poles attract, and the same poles repel. The magnets don't have to be in this shape. For example, some magnets might be more flat like this. You can think of this magnet as always on. It's always working. You can't really turn it off. That's why it's sometimes called a permanent magnet. It's made up of many smaller magnetic domains that are lined up in the same direction. But later, I'll show you a type of magnet where this is not always the case. Let's take one of our permanent magnets and drill a hole in the center and put it on something that will allow it to spin. Now bring another magnet towards it. Our spinning magnet will immediately line up until opposite poles are right next to each other. Now switch out the side magnet. The same poles repel and opposite poles attract. If we keep switching out these side magnets, then our spinning magnet will just keep spinning. This concept of the spinning magnet is really important. We'll come back to it in a moment. Here's a metal bolt which is not a magnet. It's made up of magnetic domains, but they are pointing in random directions. Now let's take a wire, wrap it around several times, and then create a circuit. The current through the wires forces the magnetic domains to line up. That means we've just made a magnet, or more specifically, an electromagnet. It can do the same things that a permanent magnet can. It can pick up pieces of metal, and it has a north and a south pole which will attract or repel other magnets. But the electromagnet is special in the sense that it can be turned on or off, just like the light bulb. You can't do that with a permanent magnet. Now watch what happens when we flip the battery. The electric current was flowing this way, but now it flows the other way. This will cause the poles on our magnet to switch places. North will become south, and south will become north. This is called reversing the polarity of an electromagnet. Instead of flipping the battery, an easier way to do this is to just switch the wires. You should be aware that the electromagnet will get very hot if it's on for a while. Just a caution in case this video inspires any science projects. Let's come back to our spinning magnet. This time we'll replace the spinning magnet with our electromagnet. As soon as we connect the wires, the magnet turns on and it lines up with the side magnet. Now, in reality, connecting these wires would prevent the bolt from spinning freely. But what's important here is the concept of the spinning electromagnet. Now let's switch the wires to reverse the poles on the electromagnet. The same poles repel and opposite poles attract. Now reverse the polarity again. Same poles repel and opposite poles attract. If we keep switching the polarity, our electromagnet will just keep spinning. To make this stronger, just like we did before. But this is a lot of work to sit here and manually switch these wires. We need to add something to the armature called a commutator. It turns on this electromagnet, which causes it to start spinning. Once we get to here, The brushes switch contact to the next pair of commutator segments, which means the torque of the motor. Electromagnets are stronger when there are more wires. This is true when we wrap more wires around the metal bolt, and it's also true when each of our armature loops are made. No matter the type of motor, most of them will produce some type of spinning motion. Once it's spinning, we can use this to make different devices move. In this case, a kid's toy. Or even a fan that cools your room. The spin
Let's understand first what is meant by electromagnet. Do you understand this experiment electromagnet? Let's move ahead. Experiment with few chemist William Watson. See, this is the William Watson, the friend of Davies, mentor of Faraday, exploring why an electronic current is applied to wire. Applied म्हणजे वायरमध्ये इलेक्ट्रॉनिकचा वापर, म्हणजे थोडक्यात वायरीमध्ये जर विद्युत प्रवाह असेल तर ती मॅग्नेटप्रमाणे काम करते. कसे ते पाहूया. हिअर इट इज इंडक्शन मोटर. इट इज ओल्ड इंडक्शन मोटर गिवन हिअर. Here are some wires. Which wires are here? See. Here are induction motor. They spread here some wires, and these wires are also connected by the motor, and from here the electricity passes. How? Let's see, understand in detail. Now do you understand how the electricity passes? So, exploring why when an electronic current is applied to a wire, it causes that wire behave like a magnet. जर एखाद्या वायरीमध्ये विद्युत असेल ती मॅग्नेटप्रमाणे काम करते. इट्स वर्क लाईक अ मॅग्नेट. व्हॉट इज द वर्क ऑफ मॅग्नेट? Do you know? Yes, everyone know it. Magnets work. Magnet attracts the things towards itself. मॅग्नेट काय करतं? आपल्याकडे विद्युत प्रवाहित करणाऱ्या वस्तू आकर्षित करते. जसं आयर्न, लोह. अशा काही वस्तू मॅग्नेट आपल्याकडे आकर्षित करते. Obviously the forces were connected, but nobody had figure out how to make it happen continuously. प्रत्येकाला हे कळत होतं की वायरीमध्ये विद्युत प्रवाह जर प्रवाहित केला ह्याप्रमाणे ते इंडक्शन मोटरप्रमाणे तर हे मॅग्नेटसारखं वर्क करते. हे मॅग्नेटप्रमाणे. पण कसे? नोबडी हॅव अ आन्सर ऑफ